In this video, we will evaluate the integral of 1 over the quantity x minus 5 times the quantity x minus 4 with respect to x using partial fraction decomposition. This approach will allow us to break the integral into simpler parts that are easier to evaluate. First, let's perform a partial fraction decomposition. We'll express the integrand as a sum of simpler fractions. So, we'll write 1 over the quantity x minus 5 times the quantity x minus 4 as a over x minus 5 plus b over x minus 4. Next, we'll find a and b by clearing the denominators. Multiplying both sides of the equation by the quantity x minus 5 times the quantity x minus 4 gives us 1 equals a times the quantity x minus 4 plus b times the quantity x minus 5. We'll distribute a and b across their respective factors. This yields 1 equals ax minus 4, a plus bx minus 5b. Next, we'll combine like terms to get 1 equals a plus b times x minus 4a minus 5b. Since this equation has to hold for all values of x, both coefficients on the left side and right side have to be equal. The coefficient of x is 0 on the left, so a plus b must equal 0. Additionally, the constant term must equal 1, so negative 4a minus 5b equals 1. Let's solve the system of equations for a and b. Solving the first equation for a, we get a equals negative b. Substituting in the second equation, we get negative 4 times negative b minus 5b equals 1. Simplifying the equation, we have 4b minus 5b equals 1, leading to negative b equals 1. Hence b equals negative 1. Substituting b equals negative 1 into our expression for a, we find a equals positive 1. Now that we have a equals 1 and b equals negative 1, let's move on to evaluating the integral. We will substitute a and b back into our partial fraction decomposition. This gives us the integral of 1 over x minus 5 minus 1 over x minus 4 with respect to x. We can evaluate this integral by splitting it into two separate integrals. The integral of 1 over x minus 5 with respect to x minus the integral of 1 over x minus 4 with respect to x. Using standard integral formulas, we evaluate this as the natural log of the absolute value of x minus 5 minus the natural log of the absolute value of x minus 4 plus the constant of integration, c. Using the properties of logarithms, we can combine these into a single logarithmic expression, yielding the natural log of the absolute value of x minus 5 divided by x minus 4 plus c. And that is the evaluated integral using partial fraction decomposition. We have demonstrated the steps to decompose the fraction into partial fractions, solve for constants, and evaluate the integrals.